Hello and welcome to the new lecture. This lecture is about Unix on a remote machine, in particular how to use Linux operating system on a remote machine, how to connect and how to utilize it. As we discussed earlier on the previous lecture, it has become more and more common for programmers to use remote servers in their everyday work. If you need to use remote servers in order to deploy backend software, or you need a server with higher computational capabilities, you will end up using a Linux server with a secure shell, in short SSH. Let's talk about SSH. SSH is a secure shell which allow you to connect to the server and then do everything you can do on your local machine in your local bash or shell. To SSH into a server, you execute a command as follows: SSH username at remote.machine.name. Here we are trying to SSH as username in a server, remote machine name. The server can be specified with a URL like remote.machine.name or an IP, something like username at number.number.number IP address. If you properly modify the SSH config, you can use a shortcut for such connect. You can shortcut, for example, SSH space remote, and with this shortcut you will connect to the shell on the remote machine. Also, SSH provides you an ability to execute commands. It works with pipes, so there are two examples. First, SSH username at server ls pipe grep pattern will grab locally the remote output of ls. That means we do ls remotely and then grab it locally on our desktop. And the second one, the second example, ls pipe ssh username at server grep pattern, this will grab remotely the local output of ls. That means we send our output of ls to the remote and then grab it there. The ability to run commands directly with SSH is an often overlooked feature of SSH, so remember it. Okay, let's continue. Let's talk about SSH keys. Key-based authentication exploits public key cryptography to prove to the server that the client owns the secret private key without revealing the key. This way you do not need to re-enter your password every time. Nevertheless, the private key, often stored in your home directory at directory.ssh in id_RSA, this is effectively your password, so treat it like so. If you generate your key with a key generation tool, preserve it as a password. To generate a pair, that means to generate a public and the private part of the key, you should use command SSH-keygen. You can see on the slide the line with key generation. I encourage you to understand each flag of this command before doing that, so please refer to man page. Here you should choose a passphrase to avoid someone who gets hold of your private key to access authorized servers. That means you can guard your SSH key with your own passphrase that you store in your head. You can use SSH-agent or GPG-agent, so you do not have to type your passphrase every time. That means if you are 100% confident that no one else has access to your computer, that you shouldn't write the passphrase every time you connect to a server. You can also check if you have a passphrase and validate it using command SSH-key -y-f and type your path to a key. So what is key-based authentication? When you connect to a server, SSH will look into .ssh directory authorized keys to determine which clients it should let in. That means which remote desktops it allows to connect. So to copy a public key over, you can use following command. You will send your public key to a server and add it to the authorized keys. Also, a simpler solution can be achieved with SSH copy ID command. It is also written on the slide, at the bottom of the slide. So for now we can connect to a server and do our work there. And when we will leave the server and connect it next time, it is no need to enter our passphrase again. We will able to connect to a server only using SSH, our user at remote. Let's go to the next topic. This topic is about copying files over SSH and downloading files on the remote machine. There are several ways to copy files over SSH. What does it mean? To transfer copies of your local files to the remote. First option is SCP. Use SCP when copying large amounts of files or directories. SCP command is very convenient since it can easily recurse over paths. The syntax is the following as you see on the slide. Also, you can use rsync. It improves upon SCP by detecting identical files in local and remote and preventing copying them again. So if you already have files on a remote machine and you don't want to send them again, use rsync. It also provides more fine-grained control over symlinks, permissions, and has extra features like the --partial flag that can resume from a previously interrupted copy. SCP doesn't provide such tools. It has similar syntax as SCP. Downloading files. How to download files when you are on the remote machine. Of course, wget will help you with that. You can use wget as on a local machine to download using URL or FTP. You can clone a repository from some Git repository available in internet or if you have some specific URL. Also, there is very helpful tool named rclone. With it you can download datasets from Dropbox and Google Drive. You might know that when you go to Google Drive file available from link, you should click a button to start downloading. And there is no a URL which you can fetch and obtain the data from using this URL. So rclone help you to get such files if you log into your Google Drive account or Dropbox account. The next topic is port forwarding. What is it? In many scenarios, you will run into software that listens to specific ports in the machine. When this happens, in your local machine, you can type localhost colon port or URL colon port. But what do you do with a remote server that doesn't have its ports directly available through the network? What does it mean? If you raise an application server on the remote server, your local machine knows nothing about this application. So you should forward the port of that application to your local machine. This process is called port forwarding, and it comes in two flavors: local port forwarding and remote port forwarding. Here I provide you images from some Stack Overflow topic. This is the most common scenario. This is local port forwarding, where a service in the remote machine listens in a port, and you want to link a port in your local machine to forward to the remote port. For example, if we execute JUPYTER notebook on port 48, we would do SSH -L, that means local, 49 colon localhost colon 48 username at remote server, and then navigate to localhost colon 49 in our local machine. What we've done here is specified that a connection made to the local port 49 is to be forwarded to the port 48 on a username at remote machine, remote server. That means if someone connects to your computer with a web browser, he gets the response of the web server running on username at remote server. You on your local machine have no web server running, but remote machine has. In the image on the slide, you can see two cases. The first case, when you raise a server on a remote host and then you want to connect to it. And the second example is when you connect to remote host, then connect to other remote host from this remote host that named faraway host. There you raise the server and you still want to connect from your local machine to that raised application. Let's talk a little bit about environment and configurations. With talking about SSH, we have covered many arguments that we can pass. A tempting alternative is to create shell aliases that look like the one on the slide. Here we alias with one word, my server, the whole long line of port forwarding and connection. However, there is a better alternative using config of SSH. It is available under .folder ssh/config. Here we can modify configuration to not type this whole command every time. But you can still add alias to your bash rc file, but it has disadvantages. The advantage of using SSH config file over aliases is that other programs like scp, rsync, mosh, etc. are able to read it as well and convert the settings into the corresponding flags. If you do it with bash rc file, all this command won't work the same way if you change SSH config. So let's talk more about .files. Many programs are configured using plain text files known as .files because the file names begin with a dot. For example, vimrc, .vimrc, so that they are hidden in the directory listing ls by default. That means if we call ls without parameters. Shells are one example of programs configured with such files. On startup, your shell will read many files to load its configuration. Depending on the shell, whether you are starting a login and interactive, the entire process can be quite complex. For bash, editing your bash rc or bash profile will work in most systems. Here you can include commands that you want to run on startup, like the alias we just described, or modifications to your path environment variable. In fact, many programs will ask you to include a line to your path environment variable. So you can do this in your bash rc or bash profile file. Some other examples of tools that can be configured through .files are presented on the slide. So bash, git, vim, text editor, SSH and tmax. Tmax, it is a terminal multiplexer. This program allows you to multiplex the windows of your terminal on the remote machine. It is very useful because you do not need to connect to each. You don't need to connect several times. You can connect once and then multiply the windows for your work. The .files is your own configuration that will work on most of the systems. So how should you organize your .files? There is an answer is they should be in their own folder and under version control, so you can save it for the later use. Then you create links, symbolic links, into place using a script. This has benefits of easy installation. If you log into a new machine, applying your customizations will only take a minute. Also, it gives you a portability. Your tools will work the same way everywhere. It gives you synchronization. You can update your .files anywhere and keep them all in sync. You can change tracking. That means you are probably going to be maintaining your .files for your entire programming career, and version history is nice to have for long-lived projects. That's why you should use version control for .files. Other question is, what should you put in your .files? You can learn about your tools settings by reading online documentation, man pages, and you can follow the links on the slide to see how others organize their .files. The following topic is resources, how to inspect them. When you are working on a server, you're sharing resources with other users. It is needed to know which resources are available and how much of them used by your applications. Each process in Linux has its own PID. That means process ID. With such unique identifier, one can inspect resources used by it. For that purposes, there are a lot of useful tools. For example, top and htop. Top allows you to see how CPUs, RAM, and disks are loaded. With htop, you can see a more fancy interface that is configurable also. For NVIDIA GPUs, it is possible to call NVIDIA SMI to figure out what is going on with GPU's RAM and which processes are utilizing video cards right now. So if you see that someone, or maybe you, utilizes RAM of graphical card, but there is no computations on it, you can connect to such person and ask him or her to shut down this program that utilizes RAM. Let's continue and talk a little bit about Docker. There will be another whole lecture about Docker where you understand how it works and how to use it. Today we will only touch this technology a little bit. We will look at how to use a container, Docker container, as a sandbox. As we discussed several times earlier, you always have other users on a machine. And almost every time your user is not a root user or super user. It is highly likely that during your research you'll require more programs that are pre-installed by your administrator. With Docker technology, you can create your own sandbox on a Linux server. You will be the root user inside it, and there you can do almost everything that's needed for your research. If you are trying to sandbox an environment with persistence between starts, if you are trying to sandbox an environment with persistence between starts, you should properly write a Docker file and properly mount volumes. This will be discussed on the following lecture. Today we'll touch only the example available on the slide. Using the following command, we can create a Docker container with the memory limits, CPU limits, and GPU limits. And this container will be named FSE/student-n, and it will be created from NVIDIA Docker image. After running such command, you can enter this sandbox and do everything as a root user inside it. So you can install other programs, you can do your research, you can write a code, you can change permissions of the files. So, okay, let's finish there our quick introduction to a Docker. You can try it by yourself on your local machine. You can install Docker and then run this command to create a container. Let's talk about writing a code. Which tools we have to write a code on a server. So there are also multiple options to write a code on a server. We can divide it in two main groups. First group, write and edit code using terminal interface. For this task we can utilize tools such as Vim, EMACS and NANO. You must choose one of them to have in your arsenal, because it is quite often you need to edit something in terminal. Here at the bottom of the slide you can see the links to the videos on some tutorials on using these tools. The second group is text editors that are running as servers. For example, Jupyter Notebook or Jupyter Lab, PyCharm or VSCODE. Jupyter Notebook or Jupyter Lab can be raised on the remote. After, you can work with that using your browser. You can raise a server on the remote machine and then connect to it from your local machine. For example, you can set up VSCODE on your server, then connect to it via your internet browser, or you can set up a PyCharm instance and then connect using your local PyCharm installation. Please note that in that place would be very helpful and information about SSH and port forwarding, because these applications are servers raised on some port on the remote machine and you want to connect to it. So let's go to the finish of our today's lecture. Let's sum up. Today we've discussed several how-tos. First of all, now we knew how to connect to a server with SSH and how to copy and download files there. After that, we've told about DOTFILES, how to configure your own environment. We've discussed also how to define available resources on a server, how to set up a sandbox to do your development separately from the other users, and also how to write a code on a server. Which options do we have if it is only command line available, or if we can raise an application server. Okay, that's it for today, and thank you.